Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 2 exam for February-March 2019. So let's get started. Question 1 says, which row shows the best choice of measuring instruments to obtain accurate values for the distances shown? For the diameter of wire, height of bench, length of a laboratory. For the wire, that's a very small distance, so we cannot use a measuring tape or a meter rule. We need a micrometer to measure the small distance accurately. For the height of a bench, we can use a measuring tape or a meter rule. We do not use the micrometer. For the length of a laboratory, that's longer than 1 meter. So we cannot use a micrometer, we cannot use a meter rule, we need a measuring tape. So the common choice here is D. Question 2 says an object is moving with uniform deceleration. Which statement describes its motion? The rate of change of speed is decreasing. No, it should be constant since it is uniform deceleration. The speed is constant. No, because the speed is decreasing in a deceleration. Its speed is decreasing. Yes. Its speed is increasing. No. So the answer is C. Question 3 says the graph shows how the speed of a car varies during part of its journey. What is the value of the car's acceleration between 6 seconds and 10 seconds? So from here to here. And the acceleration is equal to the gradient of a speed time graph. So we use these 2 points here with y2 equal to 15, y1 equals 10. So y2 minus y1 over x2 minus x1. We have 10 and 6, 10 minus 6. That would give an answer of 1.25 meters per second squared. So we choose C. Question 4 says the gravitation field strength on the moon is less than on the Earth. Which of these is different when done on the moon compared with when done on the Earth? So we have the gravitational potential energy gained by a stone lifted through the same vertical height. So potential energy is mgh. It depends on the gravity field strength. So that would be different. The kinetic energy gained by a ball when hit with the same force for the same period of time. That's the same impulse, so it would be the same change in kinetic energy. The momentum gained, that would be the same impulse again. The work done in accelerating a stone from rest to the same speed, so that's the same change in kinetic energy, so it would be the same work. So all these will remain the same, only A would be different, so we choose A. Question 5 says the mass of a full bottle of cooking oil is 1.30 kilograms. When exactly half of the oil has been used, the mass of the bottle plus the remaining oil is 0.90 kilograms. What is the mass of the empty bottle? So we can get the mass of half the oil. So we can subtract 1.30 minus 0.90. That would give us 0.40 kilograms. So the mass of half the oil in this bottle now is 0.40 kilograms. And the total mass of the bottle and the oil is 0.90, so we can subtract 0.90, the mass of the bottle and half the oil, minus the mass of half the oil. So we get the mass of the bottle, which is equal to 0.50 kilograms, so we choose B. Question 6 says a solid ball has a volume of 4 centimeter cubed. The density of the ball is 1.6 grams per centimeter cubed. What is the mass of the ball? So mass is equal to density multiplied by volume. So we multiply 1.6 times 4 to get an answer of 6.4 grams, so we choose D. Question 7 says the extension log graph for a spring is shown. The unstretched length of the spring is 15 centimeters. When an object of unknown weight is suspended from the spring, the length of the spring is 16.4 centimeters. What is the weight of the object? So we need to get the extension first. The extension is equal to the new length minus the original length, which was 15. That would give an answer of 1.4 centimeters. So we use that on the y-axis to get the load. So here's the 1.4 and we go to the graph and see what that gives on the x-axis. That gives an answer of 3.5 newtons. So we choose C. Question 8 says a box of mass 2 kilograms is pulled across the floor by a force of 6 newtons. The frictional force acting on the box is 1 newton. What is the acceleration of the box? So we have the force and mass, so we can calculate the acceleration is equal to the resultant force divided by the mass. But we have two forces here, one with the motion 6 newtons and one against the motion 1 newton. So the resultant force is equal to 6 minus 1 and we divide by the mass 2 kilograms to get an answer of 2.5 meters per second squared. So we choose B. Question 9 says which moving object has a resultant force acting on it? A diver rising vertically through water at constant speed. So we have constant speed, that means forces are balanced, so no. An aircraft circling an airport at constant speed. Yes, we are moving with constant speed, but circling means there is a change in direction. So there is a change in velocity, which means there is an acceleration. So this needs a resultant force. A train going up a straight incline at constant speed. Again, no change in speed or direction. A parachutist descending vertically at terminal velocity. No change in speed or direction. So we choose B. Question 10 says a constant force acts on a body, causing the momentum of the body to increase. Which expression relates the force to the momentum and time taken? So force is equal to the change in momentum per unit time. So change in momentum over time taken, that would be the answer. So we choose A. Question 11 says a car of mass 1,500 kilograms has a speed of 20 meters per second. It accelerates until its speed is 25 meters per second. What is the increasing kinetic energy of the car? So we can calculate half mv squared minus half mu squared, or we can take half m as common factor and then calculate v squared minus u squared. So this is half times the mass 1,500 times 25 squared minus 20 squared. That gives an answer of 168,750 joules. So we can approximate that to 170 kilojoules. So we choose C. Question 12 says which source of energy uses the production of steam to generate electrical energy? In a hydroelectric power station there is no steam. In nuclear power station there is steam. Tides and waves do not convert water to steam. So we choose B. Question 13 says a car traveling on a straight horizontal road has 1.6 megajoules of kinetic energy. It accelerates for 20 seconds until it has 2.5 megajoules of kinetic energy. What is the average power output used to increase the kinetic energy of the car? So we can say that the power is equal to the change in energy over time. So there is a change in energy from 1.6 to 2.5, so 2.5 minus 1.6, but that's times 10 to the power of 6 for mega, and then we divide by the time, which is 20 seconds. That gives an answer of 45,000 watts, which we can say is equal to 45 kilowatts, so we choose C. Question 14 says which diagram shows an athlete exerting least pressure on the ground? So for least pressure with the same weight, we need the largest area, so the largest area is drawn in B. Question 15 is about manometers, which was removed from the syllabus, so you can skip this one. It says the diagram shows a U-tube manometer containing 3 liquids, mercury, liquid X, and liquid Y. Neither liquid X or Y mixes with mercury. Which row compares the pressure exerted by the liquid X and liquid Y on the mercury and the density of liquid X and density of liquid Y? So for the mercury levels, they are equal, which means the pressure at this point is equal to the pressure at that point. So not greater, it is the same. And for the densities, pressure is equal to rho GH. So the greater the height, the lower the density for the same pressure. So liquid X has a greater height, which means it has a less density. So density of X is greater than Y, or Y greater than X. So Y greater than X. And the common choice here is D. Question 16 says gas molecules exert a pressure when they collide with the walls of a container. Which statement is correct? They experience a change in force which exerts a pressure, no change in momentum. So change in force is wrong, change in momentum yes. Which exerts pressure equal to the force multiplied by the area or force divided by the area. It's force over area, so we choose D. Question 17 is about thermometers, so you can skip this question for the new syllabus. It says a thermometer has graduations which start at negative 10 degrees Celsius and end at 110 degrees Celsius. What is the lower fixed point and what is the upper fixed point of the Celsius scale? These are the points of the melting and boiling of pure water. So the lower fixed point is 0, the melting point of ice, and the upper point is boiling of water, which is 100 degrees Celsius. So we choose C. Question 18 says a 1 kilogram block of aluminium requires more thermal energy to raise its temperature by 1 degree Celsius than 1 kilogram block of copper requires. Why is this? This would be because copper has higher specific heat capacity than aluminium, since they have the same mass and there is the same change in temperature. So the one that needs more energy has higher specific heat capacity. So not about conduction. Higher specific heat capacity. Aluminium has higher or lower specific heat. So aluminium here needs more energy, which means it has a higher specific heat capacity. So the answer is C. Question 19 says 4 campers are warming their food on a fire. They use different rods, each of the same dimensions, to hold their food near the fire. Which material is the best choice to prevent their hands from getting too hot? Which means we need a poor conductor or an insulator. So aluminum is a good conductor, copper is a good conductor, steel is a good conductor, wood is a poor conductor. So we choose D. Question 20 says two metal cans are identical except that one has a shiny silver outer surface and the other has a dull black outer surface. They each have 300 grams of water at 80 degrees Celsius sealed inside them. They are both in a vacuum in the darkness of outer space. How does the temperature of the water in each one change? So there would be no conduction or convection in space, but there will still be radiation, and 80 degrees Celsius is hot. So there will be an emission of heat, so they will cool down, so neither one will cool down is not accepted. The water in the black can cools more slowly. No, that would be emitting more quickly, so it will lose heat more quickly. Water in the shiny can cools more slowly than that in the black can, yes, because silver or shiny surfaces are poor emitters of heat radiation. Both cool down at the same rate, no, so the answer here is C. Question 21 says the diagram shows a wave before it reflects from a barrier. Which labeled section of the diagram represents a wavefront? So these lines are the wavefronts, the parallel ones to each other. So A is the direction of the wave, B is the wavelength of the wave, C is one of these lines, so the answer is C, and D is the reflecting surface, not one of the wavefronts, so the answer here is C. Question 22 says a vibrating object produces ripples on the surface of a liquid. The object completes 20 vibrations every second, that's the frequency. The spacing of the ripples from one crest to the next, that's the wavelength, is 3 centimeters. What is the speed of the ripples? And the speed is required in centimeters per second, so we do not need to change this value. And the speed is equal to the wavelength multiplied by the frequency, so 3 multiplied by 20, that gives an answer of 60 centimeters per second, so we choose C. Question 23 says a narrow beam of light is traveling through a transparent liquid. It meets the surface as shown at an angle of incidence of 40 degrees. The refractive index of the liquid is 1.5. What is the angle of refraction as the light enters the air? So the equation for refractive index is equal to sine the angle of air over sine the angle in the medium. So we have 1.5 is equal to sine the angle of refraction, which is required, over the sine of the angle in the medium, which is 40. So we multiply 1.5 times sine 40, and then we do the reverse sign. So after multiplying 1.5 times sine 40, we press equal and then shift sign answer. That would give an angle of refraction of 74.6186, which we can approximate to 75 degrees. So we choose D. Question 24 says which diagram correctly represents rays of light passing through a converging lens in a camera? So for rays in A, the rays pass through the optical center and move straight forward. That would be a correct ray. Any ray passing through the optical center will not be deflected. In B, we have rays that are parallel to the principal axis. These should go towards the focal point, so these rays are wrong. For C, we have the rays continuing straight but not passing through the optical center, so C is wrong. And for D, again, passing straight through without moving through the optical center, again, D is wrong, so we choose A. Question 25 says what is the speed of X-rays in a vacuum and in air? They are both the same and are equal to 3 times 10 to the power of 8. So C or D here, and here we have 3 times 10 to the power of 8 again, so we choose D. Question 26 says a sound wave passes a point. The air pressure at that point increases and then decreases 300 times every second. Which descriptions apply to this sound wave? So sound is a longitudinal wave, not a transverse wave. And the frequency of the sound outside the human hearing range, 300 times per second, that's 300 hertz, which means it is within the range of human hearing, which is from 20 hertz to 20,000 hertz. So within the human hearing range, so we choose B. Question 27 says a boy stands 150 meters from a wall. He claps, and when he hears the echo, he immediately claps again. He continues this for some time. Another student has a stopwatch. She starts the stopwatch on the first clap and stops it on the 11th clap. So 10 intervals have passed, and reads 10 seconds on the stopwatch. So 10 seconds for 10 intervals between claps. So 10 divided by 10, that's the time for one sound wave to go and come back as an echo. So the time is equal to 10 divided by 10, which is 1 second. And for an echo, we need to calculate the speed of sound in the air. The speed for an echo is equal twice the distance over the time, going backwards and forwards. So we have 150 times 2, and then we divide by the time for one interval, which is 1. So we get 300 meters per second. So we choose C. Question 28 says the ends of three metal rods are tested by holding NQ of rod 1 close to the others in turn. The results are as follows: NQ attracts R and NQ attracts S. So both are attracted. That means that's a magnetic material, but it is not a magnet because it does not have poles. So one pole should be repelled by Q. The next are NQ attracts T and repels U. So this is a magnetic material, but it is magnetized because one of them is north and the other is south, and this must be a magnet also because it is repelled. Any repulsion ensures that both objects are magnets. So which of the metal rods is a magnet? We have rod 1 should be a magnet and rod 3 should be a magnet. So 1 and 3 only, so we choose C. Question 29 says a metal sphere is charged by induction. There are 4 stages W, X, Y, and Z in this process. W says a charged rod is brought near to the sphere. The sphere is earthed in X. The charged rod is taken away from the sphere in Y. The earth connection is removed in Z. So the normal arrangement would be we bring the charged object first, then we earth the metal by connecting it to the ground, and then we remove the earth connection, then we remove the charged object. So this is the arrangement. So in order of the 4 stages, we need to start with W and we need to end with Y. So we choose B. Question 30 says which electrical quantity is defined in terms of the energy supplied in driving charge around a complete circuit? That would be potential difference or electromotive force. But since we are moving around a complete circuit, that would be an electromotive force of a power supply, not potential difference. Potential difference would be between 2 points in the circuit, not the whole circuit. So here we choose B. Question 31 says a student sets up a circuit containing a battery of 2 cells and 3 lamps as shown. What is the circuit diagram for this arrangement? So we have in series the battery with 1 lamp and then a parallel connection of 2 lamps. So series here and then 2 lamps in parallel, that would be the one. So we choose A. Question 32 says in which circuit does the lamp light? So we have to check the direction of the current and the diodes connected. So if the current is traveling in this direction, it would not be allowed to move through this section and will not be allowed to move in the upper section either because of the reversed diodes. In the second one, we have the current going this way. It will not be allowed in this direction or this direction because these diodes are connected in reverse. Here we have the direction in forward and another forward direction for the diode, and that would allow the current to flow. So we choose C. Indeed, this diode is connected in reverse, so it will not allow current to flow. So again, the answer is C. Question 33 says each potential divider is placed in a circuit with a power supply. Which potential divider makes the potential difference across component Y increase when the light intensity increases? So we need an LDR here, not a thermistor, so C and D are rejected. So when the light intensity increases, the resistance of the LDR actually decreases. So the voltage across the LDR decreases and we want the potential difference to increase. So Y would not be the LDR. Y would be the other component in series. So X is the LDR, Y is the other component or the fixed resistor, so we choose A. Question 34 is about logic gates, so you can skip this question for the new syllabus. It says there are 2 inputs to combination. It says there are 2 inputs to the combination of logic gates shown and 1 output. Which truth table represents the action of this combination of gates? So we have a NAND gate connected to a NOT gate, which reverses the output of the NAND and converts it to an AND gate. So for an AND gate, all the outputs are 0 unless the 2 inputs are 1. So we choose here A. Question 35 says the current in a kettle is 10 amperes and the kettle is protected by a 13 ampere fuse. The owner of the kettle replaces the 13 ampere fuse with a 3 ampere fuse. what happens when the kettle is switched on? So the kettle will draw current of 10 amperes, which is too much for the 3 ampere fuse, so the fuse would blow. So the options are: the fuse melts and the kettle might be damaged. No, the kettle will not work, so it will not be damaged. The fuse melts and the kettle is undamaged. Yes. The fuse does not melt. No, it will melt because the current is too much, so we choose B. Question 36 says, which statement about the direction of a magnetic field at a point is correct? It is the direction of the force, yes, on a north pole, a south pole, or opposed to a negative charge. It is not related to charges, it is related to poles, but it is the direction of the force on a north pole, not a south pole, so we choose A. Question 37 says a current carrying coil is placed in a magnetic field. Which effect does the coil experience? Is it a change in the shape, change in weight, resultant force, or turning effect? So if the current is moving across the coil in one direction would be upwards and the other direction would be downwards. So one side of the coil would experience an outward force and the other would experience an inward force. These forces are equal in magnitude and opposite in direction, and there is some distance, perpendicular distance between them, that would create a couple and cause the coil to rotate. So it would be a turning effect, so we choose D. Question 38 says, what are isotopes of an element? Atoms of different element? No, it is the same element with different number of neutrons or different number of protons. It is different number of neutrons, so we choose C. Question 39 says a radioactive isotope of carbon is carbon-14, decays by beta emission to give an isotope of nitrogen-14 and the beta particle. The equation for the reaction is shown. We need to know the values of x and y. So y should be memorized. It's -1 for the beta particle, and 7 minus 1 would give us in the end 6. So x is equal to 6. So we choose A. Question 40 says a beta particle is a fast-moving electron. Which statement explains how beta particles are emitted from an atom? An electron is emitted as a beta particle from an inner electron shell. No, it's from the nucleus, not from the shells. So neutron changes into a proton and a beta particle is emitted, or a proton changes into a neutron and a beta particle is emitted. It's the change from a neutron to a proton, so we choose C. So this was the end of the exam. I hope you enjoyed this video and found it useful. Please keep practicing and I will see you in another video.